artificial intelligence. And so we have 3 panel members assembled today that will introduce, and they're going to tell you about some of their work in this area. And I've struggled with this concept of education for artificial intelligence because it seems like it's a topic that really has to build off of other topics. It seems like artificial intelligence needs a whole bunch of foundational skills before you can even begin to work in this area. So looks like we're getting Jake set up, but I guess the first thing would be to meet our panelists, and I'll sit back down here. And Dr. Wang, if you would just start and tell us a little bit about yourself. And like I say, I want this to be interactive, like anyone watch those Sunday morning discussions that are somewhat unscripted, Sunday morning news programs. That's what I want this to, I'd like this to be. So it means that I need to be quiet, right? Yeah.
And so feel free to drop it in that. So my name is Diane Wang. I'm an assistant professor in the Department of Agronomy, and I started at Purdue in January of 2020, which was the best timing ever. So I'm formally trained in plant breeding and genetics, and my group here, we work on crop genetics, physiology, and we develop computer simulation models to try to make predictions of how crop species might respond to changing climates. Stop there.
No, that's good. That's good for now. You can elaborate more. And Dr. Raturi, you're an ADE, I understand. Yes.
Indeed. So hi folks, I'm Ankita Raturi. I'm an assistant professor in agricultural biology and engineering. I am a computer scientist by training, but I've spent my career really thinking deeply about informatics challenges and food environment and agriculture. And so I run a research lab. It's the Agricultural Informatics Research Lab, where we do design modeling and software engineering in service of resilient food systems. And so, you know, I live, breathe, and work these things. And so now I'm trying to teach these things as well. And so I'm really excited to be able to at least share a little bit more on that front so we can talk research another day.
Hi all. For those who don't know me, I'm Jake Hosen, assistant professor in environmental natural resources. And I do a lot of work with ecosystem science, particularly pertaining to freshwater and carbon biogeochemistry. And I have a real interest in developing and applying sensor platforms and doing that correctly. And if you're going to do that correctly, that means working with statistics and increasingly AI-related tools. And so excited to talk about that. And apologies, I'm super overcommitted today, so I'm going to have to leave right at 10 till. But if anyone wants to follow up, happy to email and set up some sort of future contact. So, thanks, y'all.
Okay, we're glad you're here. We'll extract the information here quickly for you. So, okay, so the way this will go is they'll each talk about the courses that they're teaching here and their future plans for courses and those kind of things. And then we'll get into some discussion about how data science type things should be taught and some of the methodologies, and you'll have a chance to ask questions. And so I think we're going to start with Dr. Wang here, and here are, I don't know if you want to stand up or
I'll just sit.
Yeah, that's fine. No.
So I just pulled some slides. So I gave a full length seminar last, I think, August 31st, in this seminar series where I described my course fully and sort of the philosophy behind it and kind of the things we do. So if you are interested in learning more about it, you can listen to me talk for like. So I teach a course called Agronomy 420. It's called Computing for the Natural Sciences. And basically it's fundamentals of programming and computing concepts, but for students in the College of Agriculture. So students who have taken this class come from horticulture, agronomy. It's catered more generically to the students of the College of Ag.
So we just got it approved to be added to the minor, right?
Yes, Bruce has been pushing for lots of like, oh, it counts for this and counts for that. So I'm like kind of terrified that next year this class is just going to blow up, which is a good problem to have.
You'll be fine. Yeah.
We'll get another TA.
And it's also part of the new digital agronomy matter.
Yes.
I mean, that's a requirement for that. Yeah. Yeah. So, yeah.
myself for next semester.
Yeah.
So it's taught every fall, and the motivation for this is when I first got here, the plant science faculty kind of got together, and I had a couple of different ideas for classes I could teach that were more like fundamentally in the plant sciences. And like, no, we want something more quantitative kind of skills, but it was very vague. And so I thought back to the class that I found most helpful for my graduate years, and it was actually an undergrad class. It was taught in the College of Engineering at Cornell, and the instructor there, Daisy Fan, she kindly shared a bunch of materials, and I kind of took the parts of that class that I found the most useful and the things that we've used since then and that my group commonly uses, and turned that into the first half of this class, and the second half is a little bit different. So that original class was in MATLAB. We used R for everything. No prior programming experiences needed, but I think there is a stats, intro stats requirement.
So what's the AI part of that class?
Okay, so we don't do any AI. My students use a lot of machine learning, but these are really, like Bruce mentioned, sort of more fundamental skill sets that one can develop before they go on to more advanced. That's how I really view it, as a way to lower the barriers for people who are in agriculture or forestry or entomology to not be so intimidated.
And I thought love the environment in classes, just so you know. So, but anyway, isn't machine learning a type of AI though? I mean, from my, I'm exposing my weaknesses here, but,
I think you're gonna have to ask them if
oh, are they?
Well, so
Okay.
it's if we want to think about the classification of each of these disciplines,
Yeah,
artificial intelligence is the thing that we aspire to do, right? As we think
Yeah.
about the ways in which we conceptualize intelligence, we are trying to do this thing where we create intelligence.
Mhm.
Machine learning is one of the methods that we use to be able to try and attempt some of these things in
okay.
the same way that there are techniques like computer vision that we then use to mimic perception. And so when I think about sort of the bucket of things, artificial intelligence, that's that like reach goal, like, right? That's a concept that we want to get to. And everything else that we do, we build these methods to be able to help us then start to explore what does it mean to really try to actually.
Well, that's really helpful because for the last year or two, I've been trying to wrap a definitive definition on artificial intelligence, and it's really hard to put a plain definition on it.
Yeah.
So, did you have more you wanted to say about your classes?
I don't need to, so
Oh.
that's okay. I've got some slides, but that's okay. We're gonna skip this. You guys can go online. We do a course project, lots of different topics from this year, very wide, kind of disciplinarily diverse. And I'll just slide through this.
I don't think we need to fly through it.
That's right. I'm
Okay.
done. There's some photos.
Oh.
We can just have a discussion. That's totally fine.
No, that's fine. And,
Probably more
yeah, let's
interesting.
go ahead and take a question here.
I have a question about that class. So
Yeah,
like
sure.
with those classes, I always wonder how much like time you have people, working on their personal computers doing like a specific, coding task or things versus how much is it lecture based or learning about like the theory of what machine learning is. Like how do you balance that in your classroom, and what, especially with like your specific class, how do you what is the sort of makeup of each daily class?
Okay, that's a good question. So I had that syllabus up there, which was impossible to read, but basically what we do is every third class is a lab, it's a hands-on lab, and that lab has two components. So we talk about, like, there are certain topics we move through. So one could be about conditionals. So there might be two classes about conditionals. One class is on user-defined functions. There are two classes on that, and each one is followed by a lab class where they're doing all hands-on exercises, and we use Posit Cloud so that I can set up the lab and they can should have had a little bit more time, but basically we can set up a shared project. Each student derives that project, so they have all of the packages and things that they need, and then they get a handout, which they're basically little mini problems, and they code up their solutions. And in the class itself, what I found is really useful is to not just like blow a bunch of slides by, but have stopping points where they all in orange, all the like your turn questions where they have to do something on their own and then pick like multiple choice. So that's good.
Jake, what time do you have to leave?
Just at,
Oh, 20 after.
yeah.
Oh.
So I just have to leave abruptly.
Oh, good, okay. So, whose slides are next? Is it? Ankita's?
Pick your pick.
Okay. Well, let's go next with Dr. Raturi here and tell us about what you're teaching. And you said a couple classes,
Yeah.
and you have a brand new class, is what I understand. Yeah.
Yeah. So I've been teaching at Purdue now since 2021, and so this is the overarching question that I think I've been really interested in, both in my research but also my teaching. Right? How can we collectively engage in responsible design of information systems? That means that we need skills, we need to understand concepts, and we need to come to some agreement on the types of things that we need to learn to be able to then build the systems that we all collectively think are important. This is how I structure my lab. I think about these sort of 4 different areas of work, right? There's design, where we really need to understand the human experience of interacting with technology. There's modeling, where we then think about, well, what are those people's mental models and how do we then represent those in data structures that are actually going to be also machine readable? And then there's the concept of, right, just building the software, good old fashioned software engineering, which is changing every day, especially with the influx of new tools on this topic. In agriculture, I think it's really important to work with communities of practice. And so grounding our work in real world data with real world examples is a really big motivation, not just for my research, but the classes that I produce. So the first class, which we have a real number, I'm very excited, is ASM 532. It's an introduction to agricultural informatics. It's a QR code if you want to go look at the course materials on GitHub. And every year I update it with materials that are relevant to, right, the changing computer science environment. But the short story is, right, we spent 2 lectures. We have 2-week modules. And on Tuesday, you'll come in and we'll talk about the concept of design, let's say. On Thursday, we'll sit down and do some hands-on activities. You'll go to lab and you'll start working on a hands-on lab where you'll actually try to, for instance, put up a little portfolio page in an HTML and CSS website. The next week, then I might do some like applications in industry or applications in research. And then again, that Thursday, we're again digging into like really pragmatic stuff. And so really we flip between, right, yes, discussion, yes, lecture, but a really big part of it is both demonstrating how code works. This is how I code apparently in front of class. And so, on Thursday, sometimes you'll see me there opening up the Django application. And sometimes I'll actually insert bugs into my own code to then also do things like demonstrate things that we take for granted, like debugging or failing in front of a lot of people. Sometimes they're not on purpose, but that's kind of the structure of that course.
Since you're talking about structure here, let me just dive word a little bit.
Yeah.
When the students come to your lab, do they all work independently then? And then you're available then to answer questions, or do you have a teaching assistant, or how does that work?
Yeah, so the first year, my teaching assistant and I were at most of the labs together.
Yeah.
And now that I actually have TAs that have taken the course and then we work really closely together, the labs have evolved. So, you basically get a little GitHub page that has all of the data, all of the instructions, and that's stuff that I write every year. And so I'm updating it both because the libraries change every year, as well as because we want to introduce new modules, right? So like, in the same way that software development is iterative, our course is iterative too. And so each of these, I would say there are some that the TAs are more comfortable with. There are others where I'll have to make sure that I'm also available. And then I usually make sure that I'm available for like hands-on support. But the TAs are a really big part of what make these classes successful, because if I'm going to bring in students who have never programmed before, maybe done like an online Python bootcamp class for themselves, and now they're sitting there actually building a web app, it means that we need to be able to not just debug their code with them, but also help them understand kind of what's going on. And so we'll usually help people set up their development environment in the very first class. And then really sort of, we're sitting together. And so it's not peer coding, because we don't actually do pair development, because it becomes a little bit more complicated when you're that new and the skill level is that varied in the classroom. And so instead what we do is, right, I encourage collaboration across the group. So I encourage students to talk to each other. We have a Slack workspace where if you have a problem, ask it. Somebody else could answer it. Maybe I'll get there first. Sometimes, more often than not, students answer each other's questions even before I get there. Because again, we have that varied skill level. And so I really try to cultivate that culture of collaborative learning in the classroom. And so that's kind of how we unstructure our structure.
We'll get back into this later, but yeah, thank you.
Cool. Right, so a lot of, going out to the field, doing a lot of drawing, making some goofy faces. I love the prototypes that sometimes come out of these classes. They're very silly and sometimes very, very smart. But then I have a second course in the spring that I like to encourage students to come to, and this one is a pure grad course, right? So the first one was for both undergraduates and graduate students, and I say, the prerequisite is, are you computationally inclined, interested can you do math, right? So I would love for you to have taken a little bit of Python before that, but we start slow. Whereas for the grad course that's in the spring, so right now, it's a choose your own adventure. It's really more focused on providing space for students to be able to come in and workshop, right, their digital ag research, because oftentimes we have students who are amazingly knowledgeable and the ag side of things and maybe not as much on the computing side of things. And so again, that same culture of like, let's learn from each other and support each other while learning how to code together. And then, there's some experiential learning stuff. So we go to hackathons and so on and so forth. Have online communities for fun. There are a couple of courses that I'm currently developing, which are not in my slides, which are more explicitly on the AI front. So there's going to be a micro-credential called human-centered design of AI systems or something like that. The title isn't settled yet. But thinking explicitly about, right, how can we define artificial intelligence? How can we then alter our design methods for it? And then there is a master's in AI program, an online master's that's going to be released across the university. And so I'm contributing from the College of Ag front, specific modules that will help with interdisciplinary applications in AI. And so if we want to talk more explicit AI stuff, we'll talk about that later.
Okay, excellent.
Hopefully that
Can I
sounds
ask you a
cool.
question?
Yeah, totally.
So you say it's a master, online master's in AI.
Yeah, yeah.
There's also going to be an online master's in data science.
Absolutely. And like, I mean, it's hard, right? There's data science, it's AI, there's computer science, and they're all just like different lenses that you can use to look at the same content. And so like, in reality, it's like, we're all just trying to do computing in our area of interest.
Jake and I on that. For the sweet.
Yeah, I started compiling a list of all the various master's programs, certificates, badges perhaps, I don't know, all kinds of things. And I shared it with Dennis and it was for undergrads, there was at least, I think 10 things on there, some in agriculture, some across the university. And for grad programs, there were several. And they were, I don't know, it confused me. It didn't confuse Dennis as much as it did to me, because I think Dennis is able to sort through detail better than I am. But there's a bewildering array. It's great to have all these options, but there's a bewildering array of things. And so, Jake, what are you doing in forestry? As I know that in forestry, there's a lot of digital stuff going on.
Yeah, absolutely. And so I'm just giving kind of a snippet because you could talk, for a half hour about all the forestry applications, particularly digital forestry. This is more of an ecosystem science and sensors perspective. So one of the classes that I teach, FNR 498, it'll be a regular course next year, is environmental sensors and data. So the theme of these classes, we're in FNR, and so we're fairly applied. I do some sensor construction, but when you're in a natural resources setting, thinking about more how can students build camera traps, and so that's what you have here. There's a Raspberry Pi Zero and an infrared camera, so pretty affordable tools that students can get hands-on with. Deploy these sensors. You can see things like chipmunks, and that's where the AI comes in. And I think we could have a great discussion as well about what the definition of AI is, because it's something I was thinking about when I was preparing this. There's not really a good definition, because some folks would say, oh, AI, if it has a neural network component to it, but other folks would be more general, like you're saying, Ankita. And so I don't know what the right answer is. I don't know if there is a right answer.
The thing that makes that discussion compelling, though, is that like in agribusiness, everyone has jumped on the AI bandwagon and they're touting their AI capabilities, and it bothers me that maybe this isn't really AI.
Yeah.
And maybe it is in many cases.
Or that maybe you're being too restrictive as well. That's actually one of my the kind of the pitch that I've thrown in here, because we do apply these AI networks, but you can see, there are issues with these networks. There's the chipmunk, no animal identified, because these models still have a lot of issues with things like overfitting. And so that's one of the things that we talk about in the class is, okay, why would a model trained on wolves work for this image and not for this image? Because it seems like these wolves look very similar. It's based on pattern recognition. So what's wrong? But it's the context, it's the background will ruin these models because they tend to do overfitting. And so explaining those sorts of concepts is pretty key. And then I also have FNR 401. That's a limnology course. And in this course, I don't think that there's anything that you would call AI in the sense of having neural networks, but this is my pitch to where you shouldn't necessarily say, oh, just because it's not AI doesn't mean that it's not useful. Because for example, in data sparse situations like we often have in stream ecosystem metabolism models, Bayesian statistics work very well because you're able to use priors to pull your data, pull your variance, and get a lot more power out of data sets that are usually not as large as you'd like. Further, generalized additive models for a lot of predictive applications have been shown to work better than neural networks. And so for things that are highly, situations that are highly nonlinear, like modeling algae abundance or calibrating a conductance sensor, believe it or not, that's still an empirical calibration. In both of those cases, you have a highly nonlinear relationship. And in many cases, these GAMs are going to do a better job fitting it. So happy to talk more about the specifics of the class, but that was kind of the soapbox I presented today.
I have a question for you.
Yeah.
Yeah, go ahead. Connie.
For the Bayesian statistics, we use R. So I think that's largely like based on the community culture. So that was that particular modeling framework was developed by USGS and ecologists working together, and we just happen to use R a lot. So their stan is in the back end, but you know there's an R stan wrapper. So you're running a kind of standard Bayesian model, but it's been abstracted a bit so that an undergrad limnology student can actually run this Bayesian model.
What you would say to this, but it's sort of it. Have any of you looked into Julia? And do you think like this is, it's really popular, but we also know that the programming languages like can be shift and change over time. So how important it is for us to consider what programming language we use in our class. I am for those of you who don't know me, I'm an assistant professor. Well, not so new anymore, 1 year today. But I'm also developing a course on crop modeling, and I will have to use a programming language in my class.
Yeah.
So your thoughts would be helpful.
I mean, Julia is a great language. Haskell was too. So is Lisp. There are so many languages, especially when you start to think about really niche use cases, right? Like when I was an undergrad, they taught us C and C++ and Java. And if you're not doing enterprise software development, what are you going to use Java for, right? And so the reason why I love both R and Python is because they're good utility languages. It actually doesn't matter what language we teach because we're teaching computational thinking and the art of programming and being able to do it logically. And so in my class, for instance, those students learn Python. They also will touch HTML and CSS because they should know how the internet works. They'll touch SQL because databases matter, right? And then we'll even try to do a little bit of playing around, like unassessed playing around in the final module with OpenCV and some of the more sort of modern machine learning toolkits. Again, just because tinkering and learning how to sort of flip between languages is one of the skills that we need to be teaching our students, especially since we can't guarantee that any language is really going to stand the test of time. So I love Python. But I don't know if you all's mileage is different.
Yeah, definitely. In terms of like the computational concepts that we cover in my class, these can be taken across all languages. And so like this was a class that was converted from MATLAB to R. I chose R specifically because in my domain, my home domain, that's primarily what we use, but also there are these great resources out there, such as Posit Cloud, that kind of enable us, just like the implementation of the teaching, it's a bit easier versus trying to find a computer lab and then or having everyone bring laptops and dealing with like local machine issues. So it's a cloud-based service and it's sharing really easy.
You pointed a really interesting concept though, and I think that's very unique to the College of Agriculture. Our domains each have packages that are specialty packages. And so in that sense, right, I can't assume that if I teach somebody, I'm gonna pick on Haskell just because, right, if I teach somebody Haskell, that they're going to find the package they need for their domain. And so that's, I think, where like each of us have probably also selected our languages because of the packages that we end up needing students to be able to use. So that domain specificity is, part of the reason why we're in the College of Ag and not teaching these courses over in CS.
I think someone else had a question here. Go ahead, sir.
So, Dr. Hosen, you talked about the CNN models for object identification and stuff, and that the big issue is sort of noise in the background, and what methods are out there now to sort of deal with that, sort of be able to identify a specific object with some degree of detail in a sort of messy background?
I mean, in large part, these methods or related methods are the state of the art. But the core thing, and this is actually something I think that I try and emphasize in my class, that one of the core things that's driving making these models work at all, because that's in many cases kind of a remarkable thing, is the principle of regularization. And that's really what you have with machine learning as well. And it's just a way basically of finding the factors that are important and then shrinking down all those collinear factors that tend to mess up a standard linear model. And so that's something that's actually common between everything that we've taught, all these mathematical methods that we've talked about. But I think it's a difficult problem, and part of it is also, I think, just going to be brute force, collecting more photos, getting more data so that you have the state space. That's something, it's actually speaking with Keith Chirkower right before this, about how you can present an ecosystem model that seems to produce perfectly realistic results, but then you look back and it says, oh, there's no moisture in the soil whatsoever, and all these things are unrealistic. So, and that's because you haven't filled out your state space. You don't have all the data you need for that model. So I think that's something that's really important for people to keep in mind as well.
I have two add questions. The one part that you mentioned about regularization, and you mentioned that overfitting is the main issue. In most of the modern deep learning architectures, whether it's large language models or anything, let's say vision transformers, which are basically transformers on images, there are theoretical studies which show that there is no more overfitting possible, because the amount of space that any kind of image data set takes is in the orders of magnitude higher than what you think of as calculable, let's say, modes in the data set. So, and there's a phenomenon called double descent, you will look. So people used to think that once you get overfitting, your test loss will get higher and higher, and your let's say training error will go smaller and smaller, so it generates that. But people have since discovered that as long as you go deeper in the network and you train it for more and more, and with the added regularization, whether it's dropout or modifying the images, adding lots of Gaussian noise on the original image, so that it trains much better and much more strength to it, and so it will not face any issues of background and forward blurring. You can easily solve those issues. So so in practical terms, there is no overfitting nowadays. Like you can train a model to 70 million, like the recent, let's say GPT-4 model is rumored to be it's a Mr. Expert model of really around, I think, 80 billion for each node, and there are like 8 or 16 heads for that. So 16 into 80 billion parameters, that's what it is currently right now. And so that I think regression is kind of important, but I don't think overfitting is the issue that most machine learning models deal with right now. My second question on that is that in agriculture fields, for example, the biggest, let's say the thing that helps back really the top machine learning people to get into it, or like
maybe we should let Dr. Hosen respond to the
Yeah,
first part.
okay.
Is that okay? Before you go to part two, is that okay?
Yeah, sure.
Yeah.
I think that's a great point, and it is true that that's not a big issue in many applications, but we still see a lot of problems with bias with ecologically based models because we just don't have that many photos to work with, and so that's the problem, is that we're dealing in data sparse situations, and so sometimes that means not using necessarily the most state-of-the-art method because we just don't have the data to do it. So very disappointing a lot of the time.
I wonder if part of it, so if I can maybe just reframe some of what you're saying a little bit, right? Overfitting is one type of constraint on one class of machine learning models. Part of the skills that I think we're trying to teach in our courses is being able to identify the right constraints for the right models that you're working with. And so that's really the lesson that we want people to walk away with, is depending on what kind of problem you're solving, you might have data sparsity to deal with. You might have to actually think about something else outside what is the norm, let's say in, just high theoretical machine learning. And that's the other part where I think working with domain specific data and really being grounded in real world use cases can help with that matching problem. That's why I love the examples that you share, because you're like actually collecting real data and having students interrogate it and be really critical about it.
Yeah, just follow up on that. I was actually getting to that point, that data sparsity, especially in these kind of fields, is the main challenge. And to get that, you would need to have someone who's already trained as state-of-the-art models and figure out what kind of data they can collect. And that's a long, multi-year and long focused task. So I'm curious, does Purdue agriculture or agronomy fields in general have, let's say, a center somewhere which has, let's say, longer horizon in terms of maybe NSF grants or something, which has good funding, because it will need a lot of funding. Like the base, the people is right now like this because at Stanford, faculty got multi-million-dollar grant to label image act. Is there any proposal in the department, or is there any focus on any center or Operation National Lab or some collaboration with some national labs which has some deeper or longer horizons?
I'm going to give you a short answer. It's that there are many, right? Because agriculture and the College of Agriculture is about that diverse.
Which is the best funded?
Well, so it depends on what you're looking for, right? There are people who are spending their entire career making sure that we have really high quality cover crop images. There are others who are working on tree imagery and digital forestry. And so I think maybe just to add a little bit of specificity to the question will help you get the answer that you're looking for, right? So it really depends on exactly what genre of data and what type of problem within our very, very broad discipline that you're trying to ask. I'm sure you'll find a couple of really interesting examples. I don't know if you guys have specific ones.
All I can say is I'm really glad we're talking about this because I'm learning a lot. Yeah.
And Bruce, you're part of an AI center, aren't you?
Right, I got a $500,000 grant to do AI education as part of an AI institute based at the University of Minnesota. And so my thrust though is not so much graduate and undergraduate education, it's more professional education.
Yeah.
So I'm working on that area. And that to me is a whole different question in terms of artificial intelligence and data science. It's a whole different way of packaging that and teaching that and presenting that is important. So what are other thoughts, comments here, or other questions? Let's go with Jared in the back there first, and then we'll go with you. And this is great. This is, I've done a lot of facilitation, and what one of my mentors, facilitation mentors told me, if the conversation gets a life of its own and you're covering the topics you need to cover, just let her roll. So Jared.
Thanks, Bruce. So, you're training and educating these students in your classes, for the future, whether it's undergrads or grad students, then, that shows up somewhere else. Well, I think, maybe one spot that you can see it directly is maybe in your research labs or other folks in your department. So what are kind of some of the high level pieces of your labs that really have like a big impact on how successful students are at leveraging these different technologies on their actual their research projects?
I think one of the benefits is that we have a lot of data that are available and that are specifically locally based. So the fact that we have a lot of research properties with long-term data sets, both in ag and natural resources, I think that's a huge benefit because when my students do their limnology modeling, they're working with lakes around the region, the Wabash River, things like that. I think having a healthy amount of real data is pretty key.
Can I reframe my question a little bit?
Oh, sorry.
I was gonna ask, yeah.
Okay. What do you see the students bringing into your research labs from either these classes or other classes that make them better students and produce better research?
I'll take a stab, but I guess I'm formulating the answer as I'm thinking about it. I partially designed the class so that I wouldn't have to teach each of my students these concepts one by one. So if graduate students come in, they haven't had programming experience, they definitely run through this class. And then I know that there is a base level of being able to have at least these fundamental computational skills. And that's really helpful because we develop process-based models, but we also do analysis of data sets, and it's good to, they know how to implement a function, and they know how to design their own functions, and they know how to design algorithms, like top-down design algorithms. And it's just nice. Like if I say for loop, they're not looking at me, they've never heard it before. before. So I know that there is a base level of understanding and we have this common language that we can move forward with. So that was part of the reason I designed it.
Yeah, like that language piece, I think is one of those kind of higher level things that makes everything.
If I can maybe add on that, right? So there's like the fundamental skills that I think one of the things that strikes me is that across our college, we have lots of students who need the same set of fundamentals, right? And so at least I think the three of us and many others try to capture some of those shared fundamentals so that we're not having to teach individually. But the second part of that then is giving them space to be able to experiment and tinker with a method in a low risk environment. So that way, when they're coming into their research project, they're not implementing a neural network for the first time or building a sensor for the first time or building a web app for the first time. And so they've already learned to prototype and tinker and experiment using technology as a vehicle for their experimentation. And so it means that when my students are now thinking about, what is the topic that I'm going to actually do my dissertation on, or undergrads who are looking for research experiences, they kind of know what's in their toolbox. And so they're able to now sort of also imagine solutions within digital agriculture or within sort of different disciplines in a realistic manner, right? And I think that part has been a really big shift for me because I find that before the class, I'm seeing students come in with really big sky ideas, which I love big sky ideas, but then implementing it becomes really hard, right? And so then being able to sort of see them, be able to shape or channel their energy into then something that's a lot more specific and actually implementable in the course of X amount of time is kind of neat.
And like you mentioned, Slack and kind of that, that's one aspect of approach for team science.
Yeah.
And I think that's another one of those pieces that maybe isn't, in the syllabus, but like how to work with people and technology together.
Yeah, I think in that sense, I feel like there is a growing learning community forming among our students. I look at some folks in the room who have taken my classes, hey Harsh, and like they're still learning from each other, and those sorts of relationships are just as important because when I run into a bug, if I need to know exactly how to, like, for instance, hack a spreadsheet, I know exactly who I would go to, right? Hi, Dennis, right? And so being able to actually build that community is such a valuable part to your point.
Go ahead, Brian.
I have another question. And I just remembered it. So how do you encourage to use in your class ChatGPT?
Oh,
Yeah.
You had to ask it.
In our case, the challenge is more using Copilot if they know it exists.
Yeah.
Right, and so my
Is Copilot available to us to the university?
Tell us about the differences between Copilot and.
Sure.
Yeah.
ChatGPT is for natural language. Copilot is explicitly for having a collaborator to help you write your code. And so Copilot is a product that is released by GitHub. Not everybody has access to it. I don't know if we have access to it at the university level, but my general stance on this has been, and I know there's been really great guidance that has come out of Purdue's teaching and learning folks that includes, like, I say, if you're going to use ChatGPT to write something, give me the prompt so that I know where you started and where you ended up. Because part of the discussion or part of the way in which we're also having to change our assessments is to not just, ask them to just give me a full essay, but really have them work through the problem together. And so I think part of our challenge is going to be making sure that we're not just saying, don't use a thing because they will go use the thing. We're really inviting them to actually think about, like, what is this tool doing in my toolbox and how do I want to effectively use it? And so so in my seminar course, I went to ChatGPT and I asked it to give me a history of machine learning so that I could present it in class. And then we looked at the entire transcript because I was arguing with ChatGPT for a good couple of hours, and then interrogated where it went wrong and when it was right and how we would then kind of tweak it. And then I showed them, like, the lecture that I would have given them if I did not consult the tool to just kind of demonstrate that difference. And so I think, again, part of our challenge is going to be teaching students how to, like, use these tools for good.
Yeah, with Copilot, I wasn't sure if we had access. I haven't looked into that yet, but do you know that?
I think you do, because you can get a pro account if you have a .edu address, and so I think that includes Copilot.
Probably. But I know that you can also do, right, that collaborative coding experience can also be had using pretty much any large language model. And so, like, I will use it when I need, I'll give you an example, right? I write my slides in a package called Reveal. And it's a weird JavaScript package, and sometimes I'm looking for, like, a very specific function. And so in the past, where I would have just used Stack Overflow or just used a search engine to, like, get a sample, I will also now use a tool like ChatGPT to say, hey, can you show me a working example of how this specific function is in action? And you still have to check it. So you still have to have your reference manual open in front of you, but it's, just a different like style of working. And so I think we're probably all going to have to adjust and start to teach that style of coding.
Yeah, and also if you think about it, do you think there would be a need for us to like develop some new type of course, but not exactly like prompt engineering, but like something like how to use large language models?
I think it's probably gonna get baked into a lot. It's just the way that programming is heading. Like, I don't know if we're gonna be at natural language programming in 5 years, but we're definitely moving more towards that paradigm, I think, for the foreseeable future. So I think it just has to be kind of baked into everything. And honestly, whenever possible, trying to introduce it as early as possible.
Yeah.
These concepts in general, because it makes it a lot easier if we have things to build on in later classes.
I mean, our job is to demystify technology, right?
Mhm.
It's like when Wolfram Alpha first came out, I remember everyone was like, oh my God, everyone's gonna cheat. It's the end.
Yeah.
And now we have Mathematica. It's a really great tool. And like, I sometimes use Wolfram Alpha for like a dinky example, mostly for converting units. But, right, but like it's found a place in my toolbox. And so I think same thing with large language models. Each of us are trying to figure out like, well, when is it productive to use what is in effect, right? A word completion tool.
I'm going to throw in a question here. I know you have a question, but let me throw in mine first, and then we'll get to yours. With the humongous future impact that a lot of people are saying that artificial intelligence is going to have, specifically for agriculture, are we getting enough students in your classes? I mean, are we adequately preparing? And if not, what do we need to be doing to get more people interested in this? And this reverberates all the way down through high schools and 4-H clubs and all that kind of stuff.
So your question is there enough interest from the students? Like, is there enough demand that they're actually taking these classes?
Right, are we getting enough, are we training enough people for the future of this?
I think some of the things that you mentioned in the beginning, like having certain classes fulfill or be required for a certain degree, that's
Yeah.
part of it, because students need to be incentivized. Because they only have so many credits of time, per semester, and they have to pick and choose, and not everything can be like a selective because they're interested in it. So,
Mhm.
and some students may not know that they're interested in certain coursework until they are forced to take it, and then they're like, wow, I really enjoy this, and now I'm really excited to take more advanced classes.
Well, I gave a presentation to the Indiana, what was it, Ag Teachers Association a year ago, and I'll have to say I was somewhat disappointed in my reception, and maybe it was me, maybe they just didn't like me, I don't know, but they didn't seem as interested in digital agriculture as I thought they would be. And then my discussions with many of the ag teachers was that they were focusing a lot on maybe what I'd call more of the fun things, like flying the drones and that kind of stuff, and maybe not enough data science type of stuff. And so any thoughts on how we start interjecting this into the brains of those much younger than us?
I mean, cleaning data is not a very glamorous job, right? And I think that kind of turns a lot of people off
And how
in
are
the
we going to
beginning.
make it glamorous?
And
Yeah,
so part
yeah.
of the thing that I'm really interested in thinking about is how to encourage students to take at least one computational class, right? You don't have to become a software engineer, right? Because that's explicitly what we're not trying to do. That's a different, that's a different program. What we are trying to do is help people get just enough computational skills that they're then able to, again, have a toolbox that they can use in the thing that they're deeply passionate about, whether it's ecosystems or farms or plants, right? And I think being able to express that this isn't about turning you into a computer scientist, this is about giving you tools to then go that other thing better is part of the challenge. We're actually producing a 4-H micro module right now,
Awesome.
doing like basics,
Yeah.
and it's like in Scratch, and we teach
Yeah.
a little bit of Python, and they're, they make a little digital tree visualization, and it grows, and it's cute. And so it's basic fundamentals wrapped up in a little bit of fun. And so I think as instructors, part of our like mandate is also trying to figure out how to bring in that fun without getting really overloaded. Because doing things for fun may sometimes also be a lot of work for us too.
Well, I think as my mother once said to me, school doesn't always have to be fun. So, so a question over here.
Yes, I'm from a totally different world. I'm from agriculture economics.
Yeah,
So I'm
excellent.
a social scientist. I'm trained as an applied scientist. So data analysis and modeling and computational skills are not strange to us, but I see the applications and sometimes the tools could be very different. And so I do my like research area is in natural resource and environmental economics. So I do a lot of interdisciplinary research, working with climate scientists, agronomists, work with Dora Bowling, and many like Mahoovers and many professors within Purdue. And also we
Your
have
faculty in Ankita?
I do research. I don't
Yeah.
do teaching, so but
Yeah.
I work with Tom Hurdle's lab.
GTAP?
Yeah, GTAP, and also we invited Anita last year for our GovNet conference. So my question was really for us. I feel like this technology, all computational capacity, AI stuff, kind of a little bit out of our comfort zone.
Mhm.
Because many of our research faculties use Stata, so that is like very suitable for economic analysis. And in our lab, we heavily use R, and many of faculties do also. But I see much fewer people are using like Python or even like machine learning techniques for many reasons, not just for technical reasons, but also like it's probably more difficult for us to publish any machine learning based research for our fields. So I was wondering, is it possible to have kind of a small training kit available across the college to be able to include our social scientists? Because this seemed to be a little daunting for us at the beginning.
You mean like a set of remedial courses to ramp everyone up and all these basic skills that are needed?
Yeah, like
Yeah, we've actually talked about that some in our digital ag group.
yeah, like Tom Hurdle is offering a master level class about global change and sustainable development. So many students enrolled in that master level class from all over the campus. So it could be doing water, it could be engineer, it could be forestry. And so I also liked your idea, your proposal idea about training starting from the professionals. So even if I feel like for us, it could be a little deterring at the beginning, like where do we start? I need this all whole new setup for computing, new computing capacity. And then the next step will be, we will definitely see demand from our students. Like eventually they will ask for, oh, why don't you offer a machine learning class from AgEcon and apply that to our agriculture economic problems? Yeah. But for our faculty, probably it will start pretty slowly. Some young faculties probably already have that capacity, but most of us probably will not do it, able to do it quickly.
Yeah, if I can maybe offer a couple of things.
Sure.
I love the changing methods in social science. We do a lot of user research using social science methods. So, you know, there was a time where I had to transcribe everything, and now there are tools to be able to do auto transcription, right? We see tools like QDA Miner and Atlas TI, right? They're like Stata. These are tools for coding qualitative research, right? So transcripts. They're now beginning to integrate different kinds of natural language processing algorithms that will do some of that on their own. And I think one of the big challenges is going to be helping make sure that as social scientists continue their work, we're able to actually teach them how to use those kinds of specific skills. This is again where I think like being able to understand fundamental programming skills means that when that kind of functionality gets rolled out in your specific domain software package, you're now able to kind of start to adopt those pieces. So that's at least just a little bit on the social science side. I can always chat more about that if you're curious. But I think the other part that you pointed on, which I feel like we've talked about in the past, maybe offline, is the idea of train the trainer. Because in addition to us needing to create learning materials for students, there is a need for us to also like help each other learn skills that we each have. At least with the courses that I've been developing, we're trying to take an open courseware approach, encouraging other faculty to also think of this as part of their lifelong learning. And so we replicated our course at University of Kentucky as well as at Tuskegee through a grant that was funded by NIFA and Dr. Sarswat and Dennis were both on this as well, right? But thinking about how do you then take your materials and then use it to share amongst each other. Like, I'd love to learn your techniques and vice versa.
And I think in the beginning, like if there aren't courses available in your department per se, but to have a list and to be able to, you know, offer some suggestions for coursework when the students ask for it in Ag Econ as a start. You can send them across the college or across the different departments at the beginning, and then I think over time, you know, if there are these opportunities available for like train the trainer, the faculty will be more incentivized to learn these themselves, but also things do take a little time, but maybe some of the newer faculty that you might hire will have some of these skill sets already, and it kind of changes a little bit over time.
Yeah, I'm taking some notes and we will be discussing these in some of our future meetings. And so great ideas. We probably need to wrap up here quick, but I kept one last question here that I'm curious about. Since I work so much with professionals with like crop consultants, certified crop advisors, retailers, all those people, you know, you're mainly working with undergrad and grad students. What is a fertilizer dealer, or a crop professional, or a seed person that's working in rural Midwest? What do they need to learn about artificial intelligence or data science even? I mean, I can see some data, but what about like AI? What are your thoughts there? I'm struggling with that. I mean, they're mainly just need to click the chat GPT and.
Well, they need to also understand the limits and the power of it, right? And so
Yeah.
I think a big part of it is, again, learning how these tools fit in your toolbox, right?
Mhm.
So for instance, and I'll maybe even just pick up the online masters in AI course, right? Is
Yeah.
being designed for what they're calling AI translators and AI builders, where a lot of the folks that would call translators, right? These are folks who are not necessarily building tools, but are communicating like stakeholder needs to then eventually the builders of technology. And so when I think about technical service providers and other kinds of ag advisors, you're not just bringing a service to communities, but you're also advocating for their needs to
Mhm.
technologists or other groups that are building. And so I think thinking of themselves maybe as that bridge is one of the things that I would love. And that means then being a little bit more aware of the breadth of technology available and where different things fit into their toolbox. They're also a big part of that translation piece, right? Because if a farmer in a rural space is asking like, well, what's AI going to do to my business? Ideally, they would be empowered to be able to answer that question in a well-informed way so that we don't continue to sort of perpetuate a culture of fear of technology, but really start to think about like, how can we embrace it and make it what we want it to be, right? Thinking again back to like this idea of like human-centered design.
Excellent. I'm going to follow up with you for sure. I'm one-on-one here. So I think one of our participants here may have a question.
Can I just, I'll give a personally my answer.
Oh,
to
you
your
want to?
question
Okay, yes.
About what do those people need to know? So as an analogy, I'd say that a good mechanic doesn't necessarily memorize all the torque specs. A good mechanic just knows, will this bolt need a torque spec or not? And so in the same way,
Good
in the
analogy.
future, how are we going to make recommendations for varieties, when to apply nitrogen, how much to apply, which way to do it? It's going to be driven by models. And so,
Right.
just like all of us have had calculus and we know how to take a derivative, it's been a while since I've done it, but I appreciate the importance of them.
Mhm.
And I know what they do, what they mean. So if our future graduates understand that's what AI is, these are the principles behind it. These are the parts that make me question it. These are the parts that make me trust it. Now they'll know how to use the tools that are in the box and use them appropriately. So like Dr. Raturi was saying, we're not developing. They're not going to be the software developer, but they have an appreciation for what is good, what is trustworthy, what might not be, should be checked, that sort of thing. Like that's the caliber of critical thinker, essentially. A digital computational critical thinker is what we need to crank out.
Excellent. That's a great way to end here. Unless do you have any final thoughts on anything that you want to add here? So we need to translate these thoughts to our extension people too that work more at the practitioner level. So anyway, I thank you all three panelists, or 2+, I guess, at this point. You know, I thought the presentations were excellent. Let's give them a hand. Thank you. We do have some upcoming sessions, and we have one in, looks like 2 weeks. And so be here or be square, I guess I'll just say. And they're all here in this room, right? Yeah, okay. Okay.
You're right, folks.
Señor Vargas, venga.